Right. In the previous video, we have already talked about the use of Ohm's law in a series circuit. Now let's have a look at how Ohm's law is used in a parallel circuit. So we still have the same basic formula in which voltage can be found by multiplying electric current with resistance. Now, in the case of a series circuit, the resistance is just added resistance. But what if we have a parallel circuit just like this? Surely we can't just add the resistances together. Right, so let's label this one R1 and label this one R2, in which R1 is the resistance of the light bulb on the upper path, and R2 is the resistance of the other light bulb along the lower path. So in order to do this, we will need to find the RT, or equivalent resistance, for a parallel circuit. How do we do this? In fact, the calculation of equivalent resistance for parallel path is slightly more complicated than it is in series circuit. So we have this formula right here. It is called the sum of inverses because it is the sum of the inverse of all the resistances. So we've got this formula right here, in which 1 over the equivalent resistance equals 1 over resistance 1 plus 1 over resistance 2. Now bear with me for a second here because this is a little bit confusing. And this form may remind you of the lens and mirror formula because it follows a similar format. 1 over f equals 1 over d plus 1 over d prime, and we are going to use this formula the same way as we did the lens and mirror formula. Okay, so I'm just going to leave the formula right there, and let's establish some values. Okay, so let's say that R1 equals 2 ohms and R2 equals 4 ohms. Now, how do we find the equivalent resistance? Okay, we just have to substitute these values into the symbols. So we've got 1 over RT equals 1 over 2 because R1, the first resistance, has a value of 2 ohms, plus 1 over 4 because the second resistor has a value of 4 ohms. Okay, so this one should be R2 right here. I forgot to put the index. Now, in order to do this, you can just easily whip up your calculator, or we can just do it by hand. So we have to normalize the denominator. So it's over 4. 1 over 2 is equal to 2 over 4, and 1 over 4 is simply 1 over 4. So we've got 3 over 4 right here. But remember that this is still 1 over RT. So in order to find RT, let me just zoom out a little bit here. I'm sorry. Oops, sorry for the disturbance. Okay, so let me just zoom out a bit here. How do I zoom out? Hold on. Never mind. Okay, in order to find RT, we just have to flip the fraction. So it was 3 over 4. Now for RT, it is 4 over 3 ohms. Okay, so we just have to flip the fraction because in order to get RT from 1 over RT, we just have to flip the position. We do that with the other with the other side. So we got RT over 1 equals 4 over 3. That is how we calculate parallel resistance. Now, let's take a look at the next example in which we have 3 resistances in parallel to each other. So this is going to be slightly more complicated than before. So we've got 3 light bulbs in parallel, just like this one. All right. Now this one right here is R1, R2, and R3. Let's establish some values right here. We've got 1 ohm, the simple ones, 2 ohms, and 3 ohms. Now, we are tasked to find the total or the equivalent resistance. Alright, so we can just use the same formula, which is 1 over RT. But this time we have 3 terms, since we have 3 resistors. 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so R1 is 1 ohm, R2 is 2 ohms, and R3 is 3 ohms. So we can normalize all the denominator into 6. 1 over 1 is 6 over 6. 1 over 2 is 3 over 6. 1 over 3 is 2 over 6. And this returns a value of 11 over 6. So in order to get RT, we have to flip the fraction, remember? Okay, so the numerator becomes denominator and vice versa. We've got a total equivalent resistance of 6 over 11 ohms. Okay, now that we have already known how to calculate parallel equivalent resistance, it is time for us to apply Ohm's law in a parallel circuit. So let's take a look at yet another example in which we have to calculate the electric current running through the circuit. So let's make a circuit right here. We'll just use 2 light bulbs for now. We have a power source of 6 volts, and then we have electric current running through it. We have the first resistance and the second resistance. Let's establish some values again for the resistors. Let's put R1 equals, what's a good number? 3, okay, 3 ohms, and R2 equals 4 ohms. Okay, let's find out the electric current running through the circuit. We can use this formula. Remember, if we have more than 1 resistors, then the R right here is actually the total resistance. So the formula becomes like that. Okay, let me just fix that a bit. There we go. I'm sorry, this is not VR, this is just V, the voltage. Alright, so let's calculate the total resistance. Let's use this formula. 1 over RT equals 1 over R1, which is 3 ohms, and 1 over R2, which is 4 ohms. Normalize the denominator. 1 over 3 equals 4 over 12, and 1 over 4 equals 3 over 12. So we've got 7 over 12. So in order to find RT, the total equivalent resistance, it's 12 over 7 ohms. Right, now let's use this formula right here, this baby right here, in order to find out or calculate the electric current. Okay, so let's just make a boundary right here so that we don't get confused. Right, so the voltage is 6 volts and the total resistance is 12 over 7 ohms. Now this can get a bit confusing, so let's just do this way. 6 divided by 12 over 7. Now this is the same as 6 multiplied by 7 over 12, isn't it? So we can just cross out the 6 and 12. So 6 becomes 1 because it's divided by 6, and 12 is 2. So you got 7 over 2 amps of electricity, or if you prefer to express it in the decimal form, it's going to be 3.5 amps of electricity, or should I say electric current.